So let's look at the first one. Ronnie, how did you start the first one?
Divided 20 to 4, and then 200 to 4.
Okay, we didn't divide. We do a, what's the first thing we always do? Which stands for?
Greatest common factor.
Okay, so what was our greatest common factor? 4. So we take the 4 out, and that leaves us with k squared minus 5k minus, 50. Okay. And then, Tori, what do I do from there?
We set up your x's.
Okay, so we set up our 2 parentheses, right? 2 sets of parentheses. Good, so we've got 4 parenthesis, 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 parenthesis. Okay. Jonah, what now?
Now you find what equals into 50.
Good. So I need 2 numbers that multiplied equal 50, but add up. I'm sorry, multiplied equal negative 50, but add up to negative 5, right? So before you shout that out, okay, if we think about 50, right, 1 and 50, well, we know that's not going to work. There's no way that's adding up to 5. 2 and 25, right? There's no way that that's adding up to 5. 3 doesn't go into 50. 4 doesn't go into 50. 5 goes into 50. 5 and 10. So negative 5 times 10 is negative 50. Negative 5 plus 10 is positive 5. What do I need? I need negative 5. So what would I do? Switch it, make it a positive 5 and a negative 10. Now we have 5 times negative 10 equals negative 50. 5 plus negative 10 equals negative 5. So we've got 5 plus, k plus 5, k minus 10. Notice that I keep the 4 there. The 4 does not disappear. Okay? The 4 does not disappear. And I lost my thing here. Here we go. Okay. I'm having technical difficulties here. What's happening? There we go. Okay, let's look at number 2. Zanai, what can I do on that one?
All right, I got you. 2, you could take out 1x.
Take an x out. Good. We always look for that greatest common factor first. Sometimes there is not one, but we look for it. Okay, what's that leave me?
With x squared minus 9x plus 8.
Good. Excellent. Okay, Anya, what now?
You define like the factors.
Yeah, so, right, so I'm going to bring the x down, and then I'm going to make my 2 sets of parentheses, right? So remember, I'm working on what's inside the parenthesis now. So I need 2 numbers that multiply to equal positive 8, but add up to negative 9. So we know that's going to be 8 and 1. So here's a little trick, right? So whatever your factors are, they should match that sign, right? So they're going to both be negative. If this is positive, then my factors will have that sign, okay? And just to double check it, negative 8 times negative 1 is positive 8. Negative 8 plus negative 1 is negative 9. Okay. Okay, so let's see here. Number 3. Hunter, what did you take out of number 3? 3x, good. And that leaves us with x squared plus 9x plus 18. Thank you. Okay. So we keep the 3x, right? That doesn't disappear. 2 sets of parentheses. Give me 2 numbers that multiply to 18, but add up to 9. 6 and 3. Yeah. And we're done. Okay. Some of them are easier than others, right?
What if we don't put the 3x in the front?
Then it's wrong.
The whole thing?
Yeah. So just remember when you finish, if you were to multiply this back out again, it should equal that, right? So if you only had this part here and I multiply it back out, I'm going to get x squared plus 9x plus 18. Well, that's not what I was started with, so it's wrong, right? So we're basically, what we're saying is that this is equal to 3x times x plus 3 times x plus 6. And it is, but if you leave that 3x off, it's not equal to that, okay? So just get it, make sure as you're thinking, as we're reviewing now, just make sure you're remembering to bring that common factor down with you. Okay, how about number 4, Shayna?
You want me to tell you what I got?
Sure.
I got x plus 8. And then x minus 10.
Okay. Make sure you remember it's n, not x, but that's okay, right? X plus 8, x minus 10. So after you do it, double check, right? Positive 8 times negative 10 is negative 80, so we're good. Positive 8 plus negative 10 equals negative 2, so that's good. Perfect. All right. Tony, number 5. R minus 7, R minus 5. All right. Negative 7 times negative 5 is 35. Negative 7 plus negative 5 is negative 12. So we good?
Yeah.
No?
No, you're missing the R.
You missed the common factor, the greatest common factor. Take out an R squared. Okay. So let me... You obviously did that because you factored the inside part right. You just didn't carry it down. When we take an R squared out, we get R minus 12. I'm sorry. Can't take an R squared. R, not R squared. We get R squared minus 12R plus 35. So we bring that R down there and then it's correct. Okay. Okay, Brooke, number 6.
Take out 5.
Take out a 5. Okay, and we're left with x squared minus 2x minus 80. Is that right? Okay. So remember, bring that common factor down. Right? We've got x and we've got x. And what you get inside parentheses?
I got x minus 10, x plus 1.
Good. Perfect. Okay. And this one, right, it's the same factors as that one up there. It's just that now we've got a 5 outside. So pay attention to that because that saves you time a lot of times. Okay. Okay. Ava, how about number 7?
Take out 4.
Okay, take out a 1, but we don't really have to write the 1, right? But there's no other common factor. Good. Okay, so what did you get inside?
X minus 6, x
X minus 6, x
plus 4.
plus 4. Okay, let's check that. Negative 6 times positive 4 is negative 24. What's negative 6 plus 4? Negative 2. And what did I need? Positive 2. So what do I do? Switch the signs. Yes, switch the signs. We're going to make it a plus 6 and a minus 4. Okay. All right. Caroline, how about number 8?
I took a 2 out.
Good. K squared minus 4K minus 60 is left. Okay. Thank you very much. And then what?
Then I got x minus 10 and x plus 6.
Okay, be careful, Ray. That's K. K minus 10.
Did we do a quick?
K plus 6. Good. Not yet. Excellent. All right. Number 9. Let me see here. Damien, how about number 9?
3.
Okay.
Mm-hmm.
We're left with a squared minus, is that 17?
Yeah.
Plus 70. Okay. So we've got a in both parentheses. And what did you get?
-7, -10.
Very good. Okay. All right, last one. Caden.
Take out squared as the
Okay.
b squared minus 13 b plus 30.
Okay. So we're going to go ahead and factor that part. V in both parentheses. Okay, what'd you get?
Minus 10 and minus 3.
Good. Excellent. A lot of people had trouble with this one. Okay. So this is what our quiz is on. So just a couple reminders about your quiz, all right? Yes, sir.
It doesn't matter which group first, right?
Yeah, if we put V minus 3 first,
Yeah.
that would be okay. Okay, so a couple reminders. Make sure that you bring that common factor down with you, right? Don't just let it drop out, okay? Also, pay attention to the variable. Make sure that if it's a K, that you're writing K and not X, okay?
For number 7, we have to put the 1 outside.
No.
It doesn't matter.
No.
'Cause I didn't put it.
And then double check yourself, okay? Double check after you do it. And remember, like I showed you the other day, sometimes you just need to list your factors, right? 1 and 80, 2 and 40, 4 and 20, 8 and 10, right? Sometimes you just need to list them and go through the numbers. Does 3 go into 80? Does 4 go into 80? Does 5 go into 80? And so on, okay?
Go up to 2 and 1. I just wanna check it.
Okay. Okay, so we got our books away, our iPads away. Okay, Yana, we're gonna tutor today, so we'll have you take the quiz later, unless you feel like you're ready for it now. Just like this one.
No, I'll just tutor.
I want you to try to do this worksheet on your own. It's in Google Classroom.
You have a tissue.
I have paper towels behind my desk there. if you remember, when we first started with the factoring, I told you it will get more and more difficult, right? So we're going to continue. Thank you. We're going to continue to just level it up a little bit. So far, we've learned how to factor. What's going on here? This is not working. There we go. We've learned how to factor out the greatest common factor. And thank you. Now we've learned how to factor when the A is equal to 1. What does that mean, that the A is equal to 1? Because the worksheet said factoring A equal 1, right? Well, if we factor out a greatest common factor, so let's say that we take out a 3x and we're left with x squared plus 8x plus, let me see here, 7, okay? So what do I mean when I say that the A is equal to 1? Okay, so what we're looking at when we factor are what we call quadratic expressions, right? A quadratic is different than a linear expression, okay? So if something's linear, we have mx plus b, right? You all know that, right? Because as soon as I say a line, you're like, mx plus b, right? You get all excited. So that's good, right? A quadratic is in the form of ax squared plus bx plus c. Now, we will learn more about what to do with the a, b, and the c later, but this is a quadratic. The most notable difference in these expressions is that the x on a linear expression has an exponent of 1, or when we look at it, it looks like there's no exponent, right? But it's an exponent of 1. The exponent on a quadratic is a 2. That's the difference. That's how we know this is quadratic. When we graph a quadratic, it looks like a parabola. We will learn how to graph them a little bit later. When we graph a linear function, it looks like a line. Okay? But the big difference is that x is squared. That's how we know it's quadratic, right? So when I said that a is equal to 1, I'm referring to the number in front of the x squared. So here, the number in front of it is a 1. Today, we're going to look at quadratics where the a is not 1. So here's an example. Say that we have 3x squared plus 7x minus 6. Okay. This makes it significantly more difficult, right? If I were simply, actually, can I do that? Yeah, okay. If I were simply looking for two numbers that multiplied equal -6, but add up to 7, it's not going to work because I've got this 3 here. But in this example, also the signs are messed up, right? So we're going to use a method. Now, this is my method. This is the method I'm going to teach you. If you have a tutor and they teach you another method, that is fine. So don't be like, no, she didn't teach us that. Lots of different methods. Everybody has their own little tricks that they use. Ms. Shavek teaches it totally different than I do. Okay. But I'm going to teach it my way. The first year I taught here, I taught it both ways, and that caused confusion. So I'm not going to do that. I'm just going to teach it the way I teach it and the way I've been teaching it for 26 years, okay? But I want you to understand that there are lots of methods and techniques to this, okay? So here's what we're going to do. I call this the Murray method, right? We're going to use the Murray method. Okay. All right, everybody with me? Okay. What's presenting the problem here is the 3. So we're still looking for 2 sets of parentheses, okay? Only now I'm not just putting x in each parenthesis like we were before. Because when we multiply that out, that just gives me x squared. It doesn't give me 3x squared, okay? So what we're going to do, we're going to start with relatively simple ones where there's only one way of factoring that number. And then we'll learn how to do it when there's more than one way of factoring it. So in order to factor the 3, I have to use 3 and 1. So we're going to do 3x and 1x. That's the only way of multiplying 2 numbers together and getting 3. It's a prime number, which means it's just itself and 1, okay? So we factor the 3x squared. Now we're going to factor the negative 6. So we have options. Negative 1 and 6, 1 and negative 6, negative 2 and 3, 2 and negative 3. Those are our options for 6, okay? Well, so I'm just going to step through it. Although I know which one is the correct answer, I'm going to step through the process to show you, okay? So I'm going to start with negative 1 and 6, okay? And I write them like that. I'm going to just put a little plus here. It's positive 6, okay? So what I've done is I've set it up to check it. In order to check it, we're going to cross multiply. What's 3x times 6? 18x. Plus, what's x times negative 1? Negative 1x. What does 18x plus negative 1x equal? 17x. I need it to equal 7x. So that didn't work. So I'm going to try something different. Let's try, first, before I switch numbers, I'm going to switch the position. I'm going to put a 6 and a negative 1 there. And I'm going to try it again. Okay? So before I abandon the negative 1 and 6, I'm going to switch where they're located. So we're going to check it. 3 times negative 1 is negative 3x. 1 times 6 gives me 6x. This adds up to 3x. It's closer, but it still didn't work. Okay? As we do this, you're going to learn to recognize whether it'll work or not very quickly. Okay? So this didn't work. How about the 1 and negative 6? Will that work? Right? 1 and negative 6? That's not going to work. We're going to get negative 18 and positive 1. So that doesn't work because that doesn't add up to 7. If I switch it to negative 6 and 1 like that, that's not going to work. Okay, again, we're going to get negative 3x. So the 1 and the 6 don't work. So now we're going to go try the negative 2 and the 3. So this takes time and it takes patience, especially when you're first learning it. Once you do it for a little bit, it's going to get very quick for you. Okay. So let's try the negative 2 and 3 and see if that works, because that's the next one on my list. So we're going to cross multiply to check it. What's 3x times 3? 9x. What's x times negative 2? Negative 2x. What does this add up to? Does that one work? Yes, I need it to add up to 7x. Now that I found the correct factors, I'm going to just list them straight across. We cross multiplied to check it, but we go straight across to factor it. So this is going to be 3x minus 2, x plus 3, and we're done. Okay, so it got significantly harder when we put a number in front of that x squared, didn't it? Okay, it's a lot more work now. Okay, let's try another one. We're going to do 3x squared minus 17x minus 90. Okay. we always want to check to see if there's any greatest common factor still, and there's not. So we're okay. So we're going to factor the 3x squared. The only way of doing that is 3x and 1x. Okay. Now we have to factor the 90, right? 1 and 90, 2 goes into it 45, 3 goes into it 30, 4 does not go into 90, 5 will be 18, say 6.
Has to be a negative.
Yeah, we'll work on that. 6 and what is that? 15? Okay. 7, no. 8, no. 9 and 10. 10 and 9. All right, so we'll stop there. Okay. And then we have to, one of them has to be negative. How do I know one has to be negative? It's a negative 90, right? When it's a negative, one of the numbers has to be negative. Okay, so can I eliminate any, or do you think we can eliminate any? Yeah, I don't think 1 and 90 is going to work. So, in fact, if I look down here, 2 and 45, 3 and 30 doesn't even look like it works. So I'm going to start below that. Okay. 5 and 18. Right, 5 and 18, one of them has to be negative. Now, because this is negative here, I'm going to choose the larger number. And without even multiplying that out, I know it's not going to work. Right, because I'm only going to subtract 5, add 5 to it. This is going to be much too big. So I know that's not going to work. Okay, so you have to think a little bit. You have to use your brain. Let's try 18 and 5 like this. Okay, one of them has to be negative. Will that work? Well, if I cross multiply, I get 15x, and going the other way, I get negative 18x. So that didn't work either. Okay, so it looks like the 18 and 5 are not going to work. Okay, let's try a different number. Let's try the 6 and 15, or 15 and 6. I'll do it like that. One of them has to be negative. Okay, so checking it by cross multiplying, what do we get? When we cross multiply, what do we get? Negative 18x plus 15x. That didn't work. Okay, if I switch and put the 15 down here, I'm going to get negative 45x plus 6x. Nope, that didn't work. Should we try the 9 and 10? Okay, let's try 9 and 10. And it might be 3 and 30. I don't know. I just have to make a guess somewhere, right? Let's try the 9 and 10. I think 10 and 9 like this is how I want to put it. And this will happen. As soon as you start to write the numbers in there that are the correct ones, it's like you'll see it. And that's what just happened now. I started to write and I was like 9 and oh, wait a minute, I see it. One of them has to be negative, right? So if I cross multiply now, 9 times 3 is 27. 1 times negative 10 is negative 10. So we're real close. I've got 17x. I need a negative 17x. Put the negative on the 9, yes. Now I've got negative 27x and positive 10x. Okay, so what are my factors? Nope, you go straight across with your factors. X minus 9. Okay. It feels so hard initially. You will get quick at it. Some of you are already picking it up. Okay. You'll get quick at it. So let me give you another one. What matter, if we wrote it as x minus 9, 3x minus 10, that would be okay. Right. So what does matter is the plus 10 has to go with the 3x. So you can't do x plus 10, 3x minus 9. So that is important. That order is important, but which parenthesis goes where doesn't matter. Okay. Okay, let's look at 5x squared plus 23x plus 12. Okay, try that by yourself. Okay, let's do it together. If you didn't finish, that's okay.
I have a question.
Uh-huh.
Does it have to be a negative?
No, in this case, they both have to be positive. Okay. Tony, how did you factor the 5x squared? Yeah, 5x and 1x. Good. Okay. So now we have to factor the 12. Again, I'm going to list my choices. 1 and 12, 2 and 6, 3 and 4. Those are my choices. Okay. Is 1 and 12 going to work? No. Let's try 2 and 6. All right. So if we cross multiply, we get 30x plus 2x. So that's not going to work because I need it to be 23x. If I switch it and make it 6 and 2, then I get 10x plus 6x. That doesn't work either. So 2 and 6 didn't work. Okay. So let's try 3 and 4. And again, as soon as I start to write it in there, I see it. Okay, and that happens. That's what's going to happen. As soon as you bring it over, it's like, oh, there it is, right? 5 times 4 is 20. So 20x plus 3x, that works. So my factors are, good. There you go. Those are my factors. Okay. Now, how could we check this?
Distribute.
Yes. Good. We're going to distribute it, right? We said that these are equivalent, right? So let's distribute it. We're going to get 5x squared plus 20x plus 3x plus 12. So that's 5x squared plus 23x plus 12. So we factored it correctly. You don't have to do that every time. I just want you to see that that's how we can check it. Factoring is the opposite of distributing.
Because isn't cross multiplying it kind of checks it?
That's exactly right. And that's, if you notice what we did, right? So when we factored here, that was the 5x times x, right? When we factored here, 3 times 4, right? There's the first and the last. The inner, that's the cross multiplying thing. 5x times 4, right? 5x times 4, and then x times 3. My method is just simplifying that so you don't have to keep foiling it out. And that's where some textbooks will teach you to just form the sets of parentheses like this. Some textbooks will say, okay, try it. Make your parentheses and then multiply it out and see if it works. And keep doing that. I think that takes way too long and it gets really frustrating because you're just multiplying, right? So that's why I do it this way. This is like my shortcut version of multiplying that out. Okay? Okay. Let's see. Let's do another one. How many of you learned this in Algebra 1? Learned how to factor in Algebra 1? Okay, good. Is it kind of coming back now a little bit now that we're doing it? Okay. Did you learn a different method like slide and divide? Okay. 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 Slide and divide, by the way, is a great method for learning how to factor. The reason I don't teach it is because I teach the upper level maths, the pre-calculus and the calculus, and slide and divide takes too long to do. When we get to pre-calculus and calculus, my students need to be able to see it right away, not sit there and do the actual slide and divide. They need to be able to look at it and like, okay, got it. Okay, so that's why I teach it this way, because in the upper level math, the slide and divide takes too long, to be honest. Okay, but there's nothing wrong with learning it that way. Okay, let's do 4x squared plus 42x plus 80. Okay, what do you think? Why is this one harder? What's happening? What's going through your head?
1 and 4 and 2 and 2.
We could do 1 and 4 or 2 and 2. Yes. Let me ask you something. What's the first thing that we learned how to do with factoring? Greatest common factor. Is there a greatest common factor? Yes, there is. What is it? Does 4 go into 42?
Oh, 2.
I think 2, yeah. That's going to give us 2x squared plus 21x plus 40. Right? So remember, look for that greatest common factor first. Okay, now we're going to factor what's left inside the parentheses. Okay. Yes, Kai.
Do you have to do that? I got the answer without doing that.
What did you get for an answer?
I got 4x and then 1x and then 10 and then 8.
Okay, so here's the problem. That's not incorrect, but it's not complete. Because this still has a greatest common factor in it. So if you do that, like if you use another method and you do that, right, you have to recognize that there's a greatest common factor here and take it out. Like that. The 2 just stays there.
Okay.
2 stays there. Okay?
So then we factor the 2x squared?
Right. Let me just finish addressing Jakaya. The other thing is, Jakaya, when you factor out the 2, factoring what's left is a lot easier because you have less choices for factoring it. So although this was not entirely incorrect, it was correct, just incomplete. Sometimes when we have larger numbers, that can be really hard to do because we didn't take the greatest common factor out. So taking that out is going to make our numbers smaller, which makes it easier to work with. Okay? Okay, so now that we did that, now we're ready to factor. And of course, we only have 2x and x, right? And then 40, 1 and 40, 2 and 20, 3 doesn't go into 40, 4 and 10, 5 and 8, right? So looking at that, what do you think? Can you see anything that jumps out right away? Which one?
2x minus 8, 16.
Okay, so you want to do 5 and 8 like that? Yeah, so once you list your factors, sometimes you can see it faster, okay? So this is going to give me 16x plus 5x, which is 21x. So that's going to factor, right? We already did it up here. Don't forget your 2, that stays with it. 2x plus 5, x plus 8. Okay. Okay. We are going to stop there. I'm not going to give you homework. I'm a little nervous about that because I'm afraid you're going to forget this by Monday, but I don't feel like we're quite ready for homework yet. So we're gonna hold off on that homework.
We'll just go over it again.
Yes.
Are we gonna have a